Okay, thank you for reminding me that we were going to work on, was it number 10? Okay. Was that the only one? Okay, that's what I thought. So, let me go ahead and take a look. Can I see your paper, please? Thank you. Okay. Okay. I can see how this could be a little tricky. Would you want my help with this, yes or no? Okay. So, in case you're wondering, it says, what is the mass of the apple that, uh, by legend, hit Sir Isaac Newton in the head and discovered gravity? The downward momentum of the apple was 7.06 kilograms dash meter over second, and the mass and has a mass of 0.36 kilograms and fell for 2 seconds just before it hit Newton in the noggin. Okay? So I think what we would probably rather be looking for here is perhaps what was the final velocity. Okay? So with that, if we ask what was the final velocity in number 10, could you solve for that with the given information in the problem? Okay. First of all, what is the formula for momentum? The product for the formula for momentum is what? Okay. So here's your formula. And whether you choose to put VF behind there, that's entirely up to yourself. But now, upon reading the problem, you've read it. The next thing you should do is what? And you all agree to this. The next thing you should do is what? Write down what you know. Now, whether you choose to, that's entirely up to yourselves. But what are the consequences that you could face if you choose not to do that? Could you put the wrong variable in the wrong spot? Are there a lot of variables? Yeah, any one of them. So, does everyone feel comfortable with these problems? Is anyone not comfortable, do you think? Okay. So then if your hand didn't go up, well then you should be able to come up here and describe it then. Right? Because that's what I'm perceiving. Okay? If you're telling me that you're not struggling with these, then I would say you should be able to come up here and explain it. Does that mean that you want to? Probably not. Okay? That's just human nature, because how many of you think you would get nervous standing up here? See, now all the hands are going up. You wouldn't? No? But you don't know how to do it then. Okay. Well, plus you can be on camera. We could shut it off, though. That would make you feel better. Shut off the cameras. Okay. All right. Fair enough. Okay. So you've correctly said we've read the problem. We're going to write down what we know. So what do you know in this situation? See, that's the problem. That's why we're struggling with this, because it's saying what is the mass when it says later on it says has a mass of 0.36 kilograms. That's the confusion. Okay. So with that, we know this. Was it 0.36 kilograms? That's what I was thinking it was. Okay. Is there anything else we know in the problem? Okay. So, could you repeat that again, please? So even if it didn't say it had a momentum, does anyone feel that they're having problems knowing what variable goes where by the label? Because that's going to be a big part of once we get further into this curriculum, okay? And I think we had alluded to that in this problem. We wanted to give you time to work on these yesterday. So that's what we had done, okay? Because we'll work on this here in just a few moments. Now, do we have enough information to solve for that now? Yes. If there's 3 variables, you need to know 2 of them. If there's 4 variables, you need to know 3 of them. Okay? So with that, is there anything else we know in the problem? The time. But are we going to use that though? No. Sometimes you're given information that you're just not going to use. Is that a low down dirty trick? Yeah, probably. I think the juniors thought this was an appropriate response to that, because this is what I had said. That's lower than a snake's belly in a wheel track. Pretty low, isn't it? Low down dirty trick. Maybe that's not as funny as I thought, or maybe in a couple of years that would be more funny, or funnier, whatever the proper grammar for that is. Maybe some of you could just not care less. Just get this done, so just get it done. Okay. I'll be quiet then, except for explaining this. So then velocity equals, well, we don't know. Okay. So what's our next step going to be? Okay, so we have our formula. The formula tells you what to do. So what are we putting on the left-hand side of our equal sign? Okay, so we look up at here. The product is saying that we need to put 7.06 up there. Okay, we don't need to label that because we've taken care of that in how we set up with the information we knew from the problem. So what goes on the right-hand side then? So 0.36, what's left over? V, okay? V for velocity, particular final velocity. So now this is just probably very similar to what you're doing in algebra, solving for one unknown. Okay, so we need to get this V all by itself. So how do you do that? By you have the right idea, but you flipped it around. Yes, just tell me. Okay. And then when you do that, see, sometimes it's we know what to do, we just describe it incorrectly. Because how many of you think you're good at giving directions to go someplace? Because I think now as a society, we just plug it into our phones and just let the phone tell us where to go. But for instance, if I was to give directions to, I think it's Kingsbury Country Club today is where the meet takes place in DeSmet. So to me, how many of you would think, this is just terrible? So we get out here and we go west on 34 through Madison, keep going west until we hit Highway 25, go north until you get into DeSmet to the junction of highways 25 and 14 and go west about 5 blocks. How many of you are thinking, get away from these directions? Just tell me left and right. Is that anybody in here? Okay. I mean, okay, let's start going west, correct? This way? That, oh yeah, that's east. Yeah, we want to go that way. I guess the sun's back there. It goes that direction. So, yeah, that must mean that's west. Okay, fair enough. All right, so that's how you would solve problem number 10. And these cancel each other out. So then when you divide them two, what do we get? Approximately. Okay? 19.61. And the label for that is what? Meters per second. Do we want to square it? No, we do not. Okay? So, in all honesty, that apple was probably pretty high up in the tree. Now, is this story fairly accurate? Maybe yes, maybe no. Probably a more, I want to say, plausible scenario when a scientific discovery was made was Bernoulli was the individual who discovered this. No, I'm sorry, not Bernoulli. Archimedes. Okay? And one of the aspects that had happened was when you're talking about heavy metals, besides Metallica and Motley Crue and Megadeth and Guns N' Roses, not that heavy metal. No. Heavy metals like element number 79. Okay? Who is in gold's neighborhood? In other words, when we look at element 79 as gold, who's not too far away from the gold? In other words, 2 to the right. PB, which is, 3 to the right, sorry. Yeah. And one of the things you might think of as well, why does it say PB, but we call it lead? There's no reason that you would know that, but the Latin term for lead is plumbum. Okay? So rather than saying L or LE, the Society of Chemists, when this table was arranged, just decided we're going to use the Latin name of plumbum to describe lead. Okay? But the reason that that's relevant is the atomic mass for gold is about 197, and the atomic mass for lead was at, say, 200, 207 maybe? Yeah, 207. So think back in around that time of when Archimedes was known for discovering this, was commissioned by one of the, I don't know which king it was. I think it was the king of France. My history is maybe not as great as it should be, but the science behind it certainly is. Since these are so close together in atomic mass, one of the things that you could do, even in modern times now, is do what we call gold plating. Okay? What that would mean is, let's say, I don't have any coins on me, but I think I've got a few in my desk here. Like here's one, and I'll just use this as an example as well. Just visualize that these washers are coins as well. Okay, not very heavy, and there's a little bit of zinc in here, a little bit of nickel, and other type of alloys that we use for currency. So it would not be very difficult to melt down some gold and very lightly encase this in gold and pass this along and say, I'm not going to give you my dime. I might need 10 cents. But here's 2 gold coins. Valued, I will sell them to you for, I'm going to say the bigger one is worth $500, and that smaller one's probably worth $300. So $800 for these 2 coins. And you pay me. I'm a happy person now. Since these were gold plated, because there's lead under here instead. Gold plated, and these coins are probably worth, the weight in lead, we'll say maybe $3. That's a pretty good markup, isn't it? So $800 as opposed to $3, that's probably about we'll say a 3,000% increase. That's pretty good. But how you would know if this was gold or not is how much this would displace in water. And that's how Archimedes' principle was discovered. The crown itself, was it gold-plated? Was it not? Well, one way to test that is see how much water gets displaced by that, because a crown has an irregular shape to it, so there's really no way to measure that because of its volume. And that's really doesn't have a whole lot to do with what we're talking about now, but that just comes to mind on how some of these scientific discoveries are actually made. Okay? Not that you wanted to know that or needed to know it. You're probably not going to sleep any better tonight just because you heard that story. But anyway, beyond that, left outside, are we good? Are we on the bus? Left middle. Notice we're not spending as much time on here. Whether we understand, we're picking up on that middle, middle, and right outside. And maybe these problems, you're getting more exposure to them. It's not that they're getting easier. It's just when you get that extra amount of experience, it maybe becomes a little easier for you to solve them. Okay, so please make sure your names are on them, and I will walk around and collect them, and then we will work on that bottom problem, okay? Because there could be one similar to that on your small I don't know if you want to call it small evaluation, but it certainly counts for a little more than what these daily grades are. Thank you. Thank you. And like I said, please make sure your names are on, because maybe I'll follow, like you said, other faculty members. They heard stories to where if your name isn't on it, that must mean you didn't do it. So that means it gets circular filed. It goes in the circular file. Does anyone want to guess what the circular file is? It's the garbage can. That's right. Okay. I think you're pretty good. We won't let you forget that. Okay. So, this problem up on the board is probably just a little more difficult. It's probably difficult than what we had just finished. So, with that, you've read the problem. Some of you maybe even have it done already. Do you want to, maybe you want to work on it on your own just to see how well you may or may not understand this. Does anyone want to just work on it? And in about 5 minutes, we'll go over it. Are you thinking, I don't want to do that, I just want to work on this together? But just keep this in mind that you'll be doing this on your own tomorrow. Okay? So, which I have no problem. I'm just going to ask for your input. Who wants to work on it on their own? Because I think that's a better idea. So I think we got enough hands that went up. So go ahead and work on this for, we're still going to go over it together. We're still going to do that. But this will give you hopefully an indication of how well you may or may not understand this material. And I think that's fair. Should I even turn off the mic so people can't hear how awesome they think science is? We don't want them to hear that, do we? Or is it the other way? You would say something else on what you think of science. So, you want me to shut this off? No? Okay. Someone's going to Because if I walk around, they're going to say how awesome this is. That's right. But just keep in mind that it's personal choices whether you work on these or not. Whether you're doing it now is irrelevant, but once we work on it together, then again, that's a personal choice that you are making. You have this opportunity to allow us to help you. And that tomorrow, that just gives me the opportunity to get my flag out. Go Philadelphia or go Atlanta. Or we could not care less. No Carson Wentz? Oh, that's right. That's the NFC East. That's right. Well, they're in the easy division anyway. No, probably not. About 45 seconds. I know some of us are maybe sitting here anxiously. I need to know if I got the answer right. Now, I think I've said this story, okay? For those of you who do plan on going to college, okay? How many of you feel I'll just get my checkbook out, write out a check for $70,000? I don't know. I don't know how much a college education costs, but it's expensive. The point I'm getting at is you certainly want to take advantage of the opportunities given to you. And when I was working on a summer job, why? Are we done with this? And maybe you are. Anyone else get 8.7? And maybe that's right. But to finish that story, a young man that I was working with at the zoo is going to a fairly large university in Nebraska, so that gives you somewhat of an idea that his ACT score was 25, which is actually pretty good. He said, I just would get a couple points higher, that probably would have saved me about 10 grand a year. It's just 2 points. So it's a good idea to start setting them good habits now, because when you think about building a new AT&T stadium, since you said Dallas, okay, which that stadium is probably enormous, which most of them are. So let's say Dallas is building a new complex. So will that be ready by the 2020 season if they broke ground now? No. The 2021 season, maybe. But my point is, when you have a goal in mind here in high school, this is not a lot of time to get yourself on the straight and narrow to be successful. You're probably all going to be successful. That's our goal, and I hope so too. But since you're in high school now's when it actually starts to count. So we want good habits to start to form. Anyway, so you've read the problem. What's the next thing you're supposed to do? Okay, so we'll just take these in order. It doesn't say what a lot of these, let's say, variables are. It doesn't say the velocity is this, or the acceleration is that, or the time is this, or the momentum, or any of those. So, if a boxer swings at 15.85 meters per second squared, taking 0.81 seconds, what is the momentum if the fist, I almost said first, if the fist is about 2.1 kilograms? His swing begins at 1.89 meters per second. Now, boxing is known as the sweet science. Why would that number possibly be that large? 2.18 kilograms. It's not just the fist. It's also the what? The glove. Oh, okay. The glove. That's right. Okay? So now whether it's that, I really don't know. This problem, we're just trying to make these up for your success. So, 15.85 meters per second squared is a what? It's an acceleration. And how do we know that? Because here is our label. Okay? So the acceleration is 15.85 meters per second squared. What else do we know in the problem? What's 0.81? Seconds, and that would be time. What else do we know? Okay? But it's saying, what is the momentum? Isn't that what this might be? Since that, it's just part of it. Okay? You correctly said earlier, that's the mass. Do we know anything else in the problem? Okay, so when it says this, and we know that meters per second is a what? We know it's a velocity, and it's saying that it begins at this speed. Why is that possibly important? Why is the word begins so important? Yeah, it's saying what it started at. Okay, so the initial velocity then okay, and we're asking for the momentum, so that's what variable? Okay, that's this variable. We don't know. Well, what two things do you, because there's three variables in the momentum formula. How many of them do we know? We only know one of them. So we can't solve for momentum, can we? Because I correctly heard from someone, we need to find what? We need to find the final velocity. Because remember, when it comes to these, it's the final velocity that's associated with momentum, because this speed has not made contact yet. Okay, so that is what we are referring to. So Now we don't have to read this problem anymore. We've got all this information right here that we can utilize. So with these four variables, what can we use to help us get closer to solving for the momentum? If we have an acceleration and a time and an initial velocity, what can we possibly solve for? Just tell me. The second velocity or the final one. Those kind of go together. Okay, so what does the acceleration formula tell you to do? Where does this go in the equation? On the left side. So we've got 15.85 equals, what's on the right hand side then? Final velocity okay. Okay. So there again, how many of you are looking at this and saying, we got this darn fraction in there? This just looks terrible. But with what we've done in the past, how can we get rid of that fraction and make this a nice linear equation? What can we do to this 15.85? Put it over 1. We're not changing the value of that at all. Okay? So what is 1 times VF? It's still just VF. Okay? So we've done that. What's 1 times negative 1.89? Negative 1.89. Okay, so we've cross multiplied here. So we're going to put our equal sign there. If we cross multiplied here, what will we do with them two numbers now? Same thing. And what do we get when you cross multiply those two? 12.83. Okay? So we still have this variable we need to get by itself. Okay? So how are we going to get rid of this negative 1.89? What will we do to this side of the equation? We're going to add it. If we add to the left side, what do we got to do to the right side? So what happens to these two numbers? These two here. They cancel each other out. So now we got, was the final velocity equal now? Well, whatever it is, these two are plussing or adding one to one another, and that's going to give us 14. Okay? And that's labeled as what? Because it's a velocity, so it's what? Okay? So now that we've got our final velocity, what's our next step to get our momentum now? Okay? So what does the equation tell you to do? What is the product or momentum equal? Okay? So we don't know what our momentum is. That's why it's still an unknown. So what goes on our right-hand side now? So what's our mass? 2.18. And what are we going to do with that 2.18? We're going to multiply it by 14.72. So what is our momentum then? And label is kilograms dash meter per second. Is that close to what you got earlier? So how many of you think you can go through all of this? Oh, my calculator told me that. It was 32. Maybe you can. But we're going to reserve that for better practice as this curriculum continues. Okay? If you want to, because to me, otherwise I look at it as far as tonight, ladies, volleyball. What do you know what to expect with your opponent? Is it going to be easy or pretty tough? So otherwise, when it comes to this, oh, this is easy enough, we'll be just fine. Or this volleyball opponent, might as well put one in the win column. We got this, right? Sure. Otherwise, football Friday night, might as well put it. You might as well go tell football coach, might as well put this in the win column, right? Why not? You're shaking your head no. You telling me you got to actually go through and earn it? Why can't you just put it in the win column? Okay? How's that different than this scenario? I bet it's not. Okay? So, it's personal choices whether you choose to do this or not. Okay, so that's all I've got. Problem quiz tomorrow. Please ask questions outside of class if you need to. Find a classmate, upperclassman, another teacher, myself. Watch these videos again. You should be able to hear because the microphone is on. We will see you tomorrow.